Okay, and continuing on, we're now into an Alibaba purchase. These are what's called terminal blocks. You don't see this in houses, you see it in industry. However, there's a great reason to put it in this house. We got 176 receptacles, 192 light fixtures, and a lot of them are home run back to 10 sub panels. So we got this, I don't know, 400 or 500 wires to connect up. There's 175 circuit breakers in this house. Problem, everything works fine until you get to the point where you connect them up. It's not so hard to identify where they go. The problem is getting them under the screws. The sub panels, the boxes are too small. I don't care what they say, they're too damn small. You can't put 3 wires under a screw on a circuit breaker. Only 2 of them are going to touch. The other one falls out. You can't get 4 into the slot if it's a number 12 wire in particular. The side of the box is less than 3/4 inch away, so you have to put a bend on the end of them and try to get them into that place. It just doesn't work. However, if you have in the Philippines, we have dual circuit breakers. You break both sides of the 220. So we got basically one screw for the red side and one screw for the black side. And internationally it's blue and black, but we're using red and black. But you can put one screw in there and tighten the screw. So that lets you only have one wire on each of the screws of the circuit breakers in the panel. Real doable. So they come out through a plastic ring, basically, or a rubber connector on the bottom of the sub panel. And then we have to have somebody to connect like 4 or 5 wires. So what the idea is, you take these terminal blocks, and they fit on a rail. They snap on. They got a little place you put a screwdriver in and hold it sideways to take them on and off. But we can run these the 2 wires from the circuit breaker down to 2 of these terminal blocks. Now, that would only give you one place to connect on the other side of the terminal block. So what you do is you put like 3 terminal blocks. You know, three for the red and 3 for the black. And across the top, you put it's like a row of screws. You can maybe see it here on the right. You cut this off to whatever, however many you want to connect together. Well, we're doing 3, so we've just cut off 3. So that gives you one screw on the terminal block you came in on. Then this jumps all the other terminal blocks. So it's 1 plus 2 plus 2. That's 5 wires that can go onto a terminal, to this red wire coming out of the breaker. And I can't imagine any place I want to use more than 5 wires on one, 5 circuits on one breaker. Most of them it's going to be 1 or 2. But you can continue that as much as you want. Now these terminal blocks, the ones you're looking at right there, they're 7.7 cents a piece, 800 volt rating, 32 amps. And we got 200 of them in blue and 200 in yellow. The idea there is, the ones we're talking about, red and black, are the next ones down. They're 800 volt, 76 amps. They're also wider. They're 10.2 millimeters wide, where the standard is 6.2 millimeters wide. The width and the height is pretty much uniform across all terminal blocks, all brands. The ones for 76 amps are 18.1 cents a piece. The ones for 7.7 are 32 amps. The reason we have blues and yellows, I've got a green bond wire, runs to absolutely everything in the house has got a green bond wire. I don't care if it's a light fixture, I'm going to ground the fixture. And if it's a receptacle, it's required by Philippine code. So we got all these green wires. There's like 60 of them into each of the 10 sub panels. And then we have a white neutral wire for our 110. It doesn't go into the sub panel. It comes from the main breaker panel down there, from a toroidal transformer on a rack. And that's 5,500 watts a piece for the toroidal transformers, and there's 6 of them. We can 110 the whole town if we wanted to. Once you're paying that freight from China, you may as well buy a few or something. The material, the goods aren't that high. It's the freight that's just absolutely criminal. Anyway, we're going to connect all these green wires together. And then there's a much bigger green wire. It's like a number 6 that runs downstairs to the metal rods drove in the ground. And the white wires go down there as well, because there's nothing to connect them to in the sub panel. So that takes 80 wires out of the picture real quick. And with all these things, you have where you want to separate them. This one here looks really plain. It's just a square. This fits between the terminal blocks, and then that keeps them electrically isolated and keeps your rigid jumper bar at the top from touching. If one's positive and one's negative, or if they're two surfaces that have to stay separate. They come in different shapes for different kind of terminal blocks. Here's another one. Let's talk about a specialty terminal block on this deal. And okay, this little cutie is the reason that I started looking on Alibaba, other than the fact that it's cheaper on Alibaba. This is rated 32 amps, 690 volts. So, if I got a terminal block where this, if you've watched my previous videos, there's 14 wires that make a loop around this house through all the sub panels. And that lets you have 3- and 4-way switches to turn on your light. 3-way switches on the end of a multiple switch lighting circuit. And all the ones in between the ends are 4 wire. So, you've got these places you drop down to the switches into the various rooms out of the sub panels. And you've got the lights come to some sub panel, and since you have this ring of wires going around here, you just connect them to one of the 6 rings that's outputs to turn the light on. And so we can put a wire into the panel on one side, out of the panel going to the next panel on the other side. And then at the top, we can connect up, a lighting circuit or 2 lighting circuits, and we're still back to 1 wire under 1 screw. We only really need a 2 in, 1 out. They call it. This is 2 in, 2 out. The price isn't much different. These are 17.9 cents, 18 cents a piece. And it makes it really neat. Also, when we get down to the, oh golly, congested today. Not COVID, just congestion. I'm allergic to some kind of pollen, and I just don't know which one it is. I'm hiding in the house, but it's in here too. LiPo batteries. You have a battery management system that keeps them charging any cell too high. It looks at every one of them individually. It stops the battery from outputting if any cell goes below wherever you set it. It won't charge in high temperature conditions. It won't charge in low temperature conditions. There's like 9 things that it monitors on each cell in your entire system. So you have 17 wires on 16 cells for 48 volt. They're rated 3.2 nominal, but you charge them higher than that. I'm going to get BMSs that go to 3.6, and then I can stop charging them at like 3.4. And that gives some overhead on the BMS and overhead on the batteries. And the BMS, if it sees anything wrong, it fails to in the direction to shut it all off. Anything goes out of line, it shuts it off. So if a battery voltage goes higher than there's a hard limit and then a sort of a softer limit. If it gets near the first one, it shuts it off. If it gets to the second, the hard limit, it really shuts it off. You have to go through some shenanigans in an app to get it to come back on. Anyway, we have the leads that go to the various cells on the battery. The other side of that, this is just an intermediate test point. This would go to the BMS. On the top, we have two more. When you charge a battery to BMS, cheaper BMSs, what they'll do is when any cell gets to the upper voltage we're supposed to stop charging, it drains the power through that cell into a resistor and burns it off as heat. So it's wasting your solar panel. And they take charge, and some of them are active balancers that work with capacitors, and they take charge from one cell and move it to the one right beside it. They can't go across 6 or 7 cells to where it needs it. They just do it a step at a time. It takes them forever. They're slow. They're only 0.6 of an amp on a 320 amp hour cell. So you can guess how long it takes to get it balanced. The alternative is an external active balancer. This doesn't burn anything off. It just moves it from where it is to where it needs to be. And they're done with capacitors. And the capacitors overheat, swell up, short out, whatever. Probably the least reliable piece of your whole system is a capacitor active balancer. However, this Haltech company makes one that uses, they call it a supercapacitor. It is a capacitor, but it's kind of used for storage batteries. You can run an electric car on supercapacitors instead of batteries. So they charge this thing up off of any cell that's close to its limit. If it gets to the lower threshold limit, but you haven't hit the higher one, it starts siphoning all that off, and it charges this thing. And then it moves it to the lowest voltage cell in the pack. Now, we're ordering them at 6 amps. And the problem is with that, we can only get within 0.3, or 3 rather, millivolts of equal charge. The ones at 0.6, because they're moving such a small charge, they get to 0.1 millivolts. Much better on the batteries. Well, really, there's not any difference you'd ever notice. Oh, we're going to get on to that in a minute. I think that's enough of this stuff. We're going to end this video here because it's already too long. I know nobody watches them, but I got more chance somebody might watch one if I had it shorter, but it's not shorter. So we're going to come back with another short video.